Based on the PES data below, what would be true regarding atoms 1 and 2? All right, so I'm going to zoom in on these two spectra that are shown for atom number 1 and atom number 2. We're going to see what we can figure out. So atom 1 has 3 peaks, all containing 2 electrons. We have a very high binding energy here, 28.6, and then 2 peaks that are closer together that are slightly greater than 1. So we know that the highest binding energy peak is always the one closest to the nucleus, so that would be the 1s2, followed by the next peak, 2s2, 2p2. And looking at a periodic table, the element with these 6 electrons is carbon. Same thing for this second atom, except that the one peak has an extra electron in it. So the one with the highest binding energy is 1s2. And notice that it's higher than for the first element that we talked about, just because there's more protons in the nucleus as well. And then this is 2s2, and this is 2p1, 2, 3. Okay? So looking at a periodic table, this is 7 protons and electrons. This would be nitrogen. Okay? All right, so which of the following are true? Number 1 here. Atom 1 has a smaller atomic radii. So does carbon have a smaller atomic radii? You can look at a periodic table and say that yes, that no, it doesn't, because it's further to the left of nitrogen, right? And so nitrogen has the smallest atomic radii. But looking at the PES spectra, we can also see that that's true. We have an extra electron and an extra proton, and that increased nuclear charge pulls those outer electrons in closer to the nucleus, decreasing the radius. Okay, so atom 2 actually has the smaller atomic radius. Number 2, atom 2 has a larger first ionization energy. So comparing carbon and nitrogen on your periodic table, nitrogen is further to the right of carbon, and so it does have the larger first ionization energy. It requires more energy to remove one of those outer electrons from nitrogen than it does carbon, for the same reason that we just said before. You have an increased effective nuclear charge that's holding onto those electrons more tightly, so it requires more energy to remove them. Number 3, both atoms are in the same period. The period is the row across the periodic table, and so we can see that's true. We have an outer electron configuration in the second period for both of these atoms. So that's true. But then number 4, both atoms are in the same group. That is not true. The same group would require these electron configurations, valence configurations, to be the same. NS2, NP2, or P3, one or the other. So they're not in the same group or column. They're next to each other. So only 2 and 3 are true, which is answer choice B. Okay, let me zoom out here. You can see everything. We get answer choice B, 2 and 3 only.